Hello, my name is Nitin. We are very proud since we are the first lab in the world that purchased DAISY 8, the eighth generation of SPIAG's dosimetric assessment system. The concept of the system remains the same, but the eighth generation has been redesigned to account for the growing multi application range. DAISY 8 is ready for specific absorption rate or SAR testing, millimeter wave, hearing aid compatibility 2019 version, evaluation of frequencies less than 4 MHz, proximity sensor, and implant safety evaluations. It also includes a version dedicated to flexible R&D tasks. DAISY 8 comes with several new hardware components. These include the new TX2 robot from Stobly, a redesigned measurement server, integration of this new DAE4 IP with integrated power supply from the robot or measurement server, a quick adapter change system to rapidly change the DAE holder, the phone gripper of DAISY 8 Magpie DAS, including emergency stop and any third party probes. I am also pleased to see that the new electro optic converter interface has all the interfaces for all future products, such as the power supply, the Ethernet, the USB, the optical, as well as the pneumatic, among others. I will not be able to demonstrate all the new hardware components in a single video. So instead, today, I will focus on the new module SAR software release version 16. This software release includes many of the long awaited features, such as the possibility to combine area and zoom scans for assessment of multiband SAR, evaluation of SAR to peak location separation ratio or SPLSR, more effective measurements of the system noise, probe linearity, and general troubleshooting with the new multimeter job, a more user friendly graphical user interface that integrates tightly with the new hardware for faster robot movements and better performance, and importantly, an extended API interface. The speed improvements of DAISY 8 compared to DAISY 6 are not that impressive yet, except for the mother scan. But Spiag assured us that they will make this a priority for the next release. Back to the new features, and in particular, a very important one we have been waiting for a long time, namely the multi-band SAR post-processor. Spiag did a thorough job by allowing to combine measurements done with different systems, and they have also kept their promise and made sure that the release is 100% compatible with both the new DAISY 8 and its predecessor, the DAISY 6. Anyway, let's get started and have a look at the multi-band SAR combiner feature of the new module SAR software. I will evaluate the simultaneous transmission SAR feature for this mobile phone using the DAISY 8 module SAR v16.0 software. The phone supports the hotspot mode, and we will test the device in this mode with separate measurements for the LTE TDD band 40 and Wi-Fi 802.11b at 2.4 GHz midband. We will later combine these measurements using the new software. The antenna for these two bands is located near the bottom edge of the phone, and we will therefore scan with a grid offset to this part of the phone. First, I create a project file in the usual manner consisting of the two test cases for LTE TDD band 40 and Wi-Fi 802.11b at 2.4 GHz midband. The test cases are at the midband frequency with 20 MHz channel bandwidth. For each test case, I set user-defined grid settings to offset the area grid to the bottom edge of the phone. The area and zoom scans are widened to include both antennae. The phone is now positioned beneath the phantom. I now press start to measure the project. The LTE test case is measured first with the automatic call setup. I accelerate the video. The LTE measurements is finished. To set up the Wi-Fi measurement, I connect the device to the computer through the USB port without disturbing the device mounting position, and then use the field test mode software to set it to radiate at 802.11 QPSK mid channel. The radiation is verified on the connected spectrum analyzer screen. The USB connection on the phone is disconnected, and I now start the DAISY 8 measurement. I accelerate the video. The measurements are now finished. As we see, the 1 gram SAR values for the two cases are 1.29 watt per kg and 0.477 watt per kg. A simple algebraic addition in this case exceeds the FCC SAR limit, and a detailed evaluation is necessary. First, we click on the two area scans and combine them. This creates a new test case in the project tree. The software calculates the combined SAR for this new test case value using the Motorola Fast SAR algorithm, which assumes an exponential decay in the z direction. The combined area scan also shows the SP-LSR ratio, which is 0.110 in this case. As this ratio is more than 0.04, it means that the distributions overlap to a considerable extent. Next, I combine the two zoom scans using the same process, and the new test case in the project tree shows the combined SAR value as 1.59 watt per kg, which is within the FCC 1 gram limits. I also wanted to test the feature of combining measurement performed with different system. So I had performed the same configuration at the SAM flat phantom using our DAISY 6 system. I will try to open the file now in DAISY 8 and combine with the configuration I just measured with DAISY 8. It all works. Clicking the eye icon next to the combined zoom scan shows the combined SAR pattern in 3D window. Detailed scan reports can be generated using the Word or HTML template. The detailed reports show the individual area and zoom scan values, the combined SAR values, and the combined SAR plot. The new multi-band combiner feature of module SAR 16.0 is well implemented. It maps the measurements taken in the twin SAM phantom to the reference phantom that now enables to combine measurements performed at different systems taken in the twin SAM without impairing the precision. This works for the area and zoom scans as demonstrated. The next release will also permit combining the scans in specific phantoms such as the headstand or face down phantoms. Congratulations, Shpiag. Next time, I will also look more closely at the new features, new improvements in DAISY 8 hardware. Thanks for watching this video.